All right, you guys, so I wanted to go over 445. I know a lot of you didn't get to it, and it's going to be a big part of our final unit test. So let's make sure you really understand how to do this. So starting off with A, we have A, x squared minus 49. So if you don't have this in your notes, put this in here. Remember, there is a rule for this one, and it's called the difference, as in subtraction, of squares, as in perfect squares. And what that looks like, the reason I recognize this is here's my subtraction, okay, and I only have two terms, and the first one has degree 2, which means the exponent is 2, and the second one has degree 0, which means the exponent is 0, but when the exponent's 0, we don't actually see it. And we're subtracting. And then if you have this difference of squares, if you see this automatically, you barely have to do anything. We're just going to set up what our factored form looks like. We're going to say, what is the square root of the first term? X squared. Well, since x times x is x squared, that's the square root of x squared. Then I'm going to look at 49. What's the square root of 49? I know it has a perfect square root because 7 times 7 is 49. Okay? And because I need to multiply two numbers and get this negative, one's going to be a positive and one is going to be a negative. Okay? So that is A. But let's see, let me highlight all the ones over here I feel like are exactly like that. This one, x squared plus 4. Oops, no. It's not, it has a plus, it's not the difference of squares. This one, 9x squared minus 1, x squared minus 36, 4x squared minus 25. I think that's it. So let's go ahead and do these ones because it'll be really easy. Okay, so h, x squared minus 36, right? Well, x squared is equal to x times x, and 36 is equal to 6 times 6. That's how we know they're perfect square, because both of these numbers are exactly the same. So my answer is just going to be x plus 6 times x minus 6. Okay? What about f? 4x squared is equal to 2x times 2x. 25 is equal to 5 times 5. So my answer for f, this was h, my answer for f is going to be, this time it's going to be 2x here and 2x here, and then plus 5 and minus 5. And L, 9x squared is equal to 3x times 3x. And 1, this is a tricky one, you guys. 1 is always a perfect square because it is just 1 times 1. So L ends up being 3x plus 1 times 3x minus 1. Okay, you guys, so let's go over another trick that I can tell you, and we'll highlight these in blue. I love blue. Why don't we highlight this next set in blue? Or how about turquoise? Yep. Oops, turquoise here. Okay, and they're all going to look like this, where we have just an x squared, okay, or whatever variable squared, and then we have a negative x's, and then we have positive at the end. But the reason why I highlighted that one is because I know if you have two numbers that add up to be a negative, like here, right? And let me put I'll put an A for add, and multiply together to be a positive, we know they're going to be both negative, and since this last number is a perfect square, I bet it's going to be, pardon me, guys, I bet it's going to be that. So check this out. This one is going to be, remember, if my leading coefficient is just 1, I can already start getting it set up. And then minus 5 and minus 5. Because negative 5 times negative 5 gives me positive 25. And negative 5 plus negative 5 equals negative 10x. Okay? So let's see, this is positive 25 and negative 10. It would be negative 5 and negative 5. But let's see what else we have that matches that. We have negative, 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 and then a positive. And we have, is that it? So let's just do G. Then that's the last one we have to do. So G, it's all about looking for patterns. That's what math is all about, you guys. G, we're going to start off with, okay, the leading coefficient is 1. That means the number in front of the x squared is 1. So this is just going to be x, and this is just going to be x. They add up to be a negative, but multiply together to be a positive, so that means it's going to both be negative. And 9's a perfect square, and it looks like 3, because 3 times 3 is positive 9, and 3 plus 3, negative 3 plus negative 3 is negative 6. Okay? All right, what other kinds of patterns can we find? Well, one important thing I can tell you is that we can't factor this one. Remember how I'd highlighted that and I thought it was the difference of squares, but then realized that I was adding instead of subtracting. And the reason that's never going to work is because if I have a positive number at the end, that 4, it's always going to have to be either a negative times a negative or a positive times a positive. And when you add terms that are both negative or both positive, you're never going to get a 0. So that's not factorable. What else I was looking for was somewhere where I could factor out if something was divisible by the same number, somewhere I can factor that out, but I don't see that. 9, 12, and 4 don't have a common factor. 4, 20, 25 do not have a common factor. So let's go ahead and do this one. I think it's going to be the easiest one that we have left because we have a leading coefficient of 1. So I'm just looking for two numbers that add up to be positive 2 and multiply together to be negative 24. So they multiply to be negative. They add up to be a positive, which means one must be negative and one must be positive. The positive is going to be the bigger number. And I'm going to go with negative 4 and positive 6. So B is just going to be x minus 4 times x plus 6. It could be x plus 6 times x minus 4. It doesn't matter which way you write it. And then these other ones, it looks like I'm just going to have to do them the long way. So D, J, E, and I, we're just going to do those the long way, the box and the cross, which will be good practice for you guys. Anyway, so let's get started. I'm going to draw the box and the cross. And let's do D. So I'm going to put 9x squared here. I'm going to put 4 here. I need to split up positive 12. So I'm looking for two numbers, 9 times 4. Remember, my diagonals, whatever these multiplied together to be, these numbers also have to multiply together to be. So I'm looking for two numbers that multiply together to be positive 36 and add up to be positive 12. So both of them are going to be positive. Okay, and I'm thinking it's going to be, because 12 is that middle number, that's where, remember 12 is that middle number, that's where we get what they add up to be. And it's going to be positive 6 and positive 6. You probably already figured that out. So I'll put positive 6x here. I've got to put that x back in, positive 6x here. Then I need to factor out the sides. So Up top, 6 and 9, the greatest common factor is a 3, and they both have an x, so this is going to be 3x times 3x. And then everything's positive here, and then 3x times what is 6x? That's just going to be positive 2, and also positive 2 because we have 3x times positive 2 is 6x over here, and 3x times positive 2 is also 6x over here, right? So what are our sides? Are just 3x plus 2 times 3x plus 2. But remember, that's the same as, since these are exactly the same, we could just write 3x plus 2 squared. Okay? So you're always going to be able to have a perfect square there. All right, let's see. Let's see if I can just erase the outsides so I don't have to write everything again. My box and my cross at least. So that was D. Let's do E, and I'm gonna have to quickly go through this because I'm running out of time on my video. It only lasts 15 minutes. Actually, I'm gonna pause and set it up. All right, so if you need to set this up, quickly do that. You can pause again, but I have two numbers that need to multiply together to be -5, add up together to be -4. So one's going to be a negative, one's going to be a positive. The bigger one's going to be negative. So 5 is a prime number. It's just -5 and +1. Okay, so let's put a -5x, +1x. Let's start to factor here. Let's do this because these are both negative here. So I can take out a negative, right? Those are both negative. So I can take out a -1. That's the biggest number that can go into -1. So -1 times 5x will give me -5x. 5x times just x here. And x times 1x is just, or x times what is 1x, and that's just 1. So in this case, we have 5x plus 1 times x minus 1. Okay, I'm going to pause again and set up I. All right, you guys, so I think what they have wanted us to be realizing in this one is that if we ever have a prime number here, there is only one way to get that, right? It's going to be, oh, that's not a prime number. Never mind, then I was just kidding. I thought I was onto something. Maybe it was talking about if there's only one number difference between here and here. But it always works the long way. So two numbers that multiply together to be a negative, one's going to be negative, one's going to be a positive. And in this case, since they're so close together, it has to be -21 times +1. And they'll add up to be -20. So let's do -21x, +1x, and then I like to factor where there's two negatives because I know right away I can factor that negative out. And 3 can go into 21, so that's the biggest number. So -3 times what is -21x, and that's going to be +7x. 7x times what is 7x squared? It's just going to be 1x. X times what is 1x, and that's just going to be +1, and we can check ourselves, is +1 times -3 -3? Yes, it is. So my answer for this one is 7x plus 1 times x minus 3. Whoops, x minus 3. Okay, we just have a minute to do the last one. I'm going to pause it and then run through it real quick. All right, 4 times 25 was +100. I'm looking for two numbers that multiply to be +100, add up to be +20. And that is going to be 10 and 10. So we have 10x and 10x. All right, and I will just start here. 4x squared and 10x, they both have an x, and they can both be divided by 2. So 2x times 2x is 4x squared. 2x times just regular +5 is 10x. That 2x already has the x. And 2x times +5 here. Oh, look, we've got another one of those for exactly the same ones, right? So we have 2x plus 5, 2x plus 5. So it is 2x plus 5 squared.